Hello, everybody, and welcome back to Math 100. Today, we are going to study section 8.2. Now, in section 8.1, we studied apportionment, all right, and that had to do with choosing or calculating the number of congressional seats for a state. And that, of course, involves the fixed number of seats available to the state for each state. And that is supposed to be proportional to the population, right? And so each state is divided up into several congressional districts. How are they going to decide that? So that's the topic for today. Section 8.2 is about gerrymandering. And it is a practice, of course, you'll hear more about this, that involves redrawing the boundary of these districts. Okay, so in my virtual background, I have a map of parts of Santa Clarita. And so let's talk about redrawing congressional districts. Okay, it involves a lot of calculations, but the calculations themselves are not very difficult. Basically, all you have to do is to do a lot of addition operations. So let's take a look at section 8.2, gerrymandering. The topic of section 8.2 is gerrymandering. Okay, now let me first tell you something about the pronunciation of this thing. Okay. Gerrymandering, as you may know, it involves a practice of redrawing congressional districts, and it began probably 100 years ago. You can read more details about this practice, very political practice, in the textbook in section 8.2. But it began with a politician in Massachusetts named Gerry, but actually his name is spelled last name is spelled Gerry, but according to most documents, his name was actually pronounced Gary. So possibly, and some people still call this practice gerrymandering, but now today many people call this gerrymandering. So it depends on who you ask. Okay, technically, it may be correct to call this gerrymandering, but most people today are happy to call this gerrymandering. So as you know, the apportionment process involved drawing of the legislative districts with a goal of having each district include approximately just about the same number of people or voters or constituents. Right. However, because of this goal, a geographically small city may have several representatives, of course, right? Because a small city with lots of people could have several representatives, while a large agricultural or rural regions may have just like one legislator. And then when population changes, then it becomes important. In fact, it becomes necessary to redraw these districts which the legislators are supposed to represent. This process of redistricting is many times done by the legislature itself. So not surprisingly, these politicians that make up the legislature, often they use this for their political gain. So this practice of redrawing districts becomes a politically manipulative practice, and that politically manipulative practice of redrawing legislative districts is called gerrymandering. Okay, so that's what this is, and usually that is done to gain an advantage for one political party. Okay, so that's pretty much all I'm going to say about that, the practice of gerrymandering. And now we are just going to look at a couple of examples because, as I said before, the mathematics is not difficult. All right, so we have data, and all you have to do is to answer these questions, and then you may want to ask some more questions based on this. All right, so let me give you the first situation. Suppose we have a country, or let's say a county. Okay, a county would be a better analogy here. A county consisting of 6 areas shown below. So we have a county consisting of the big city areas. Regions 3 and 4 are the city west and city center regions, and that's very urban. All right, and then we have some suburbs, and then we have some rural areas. Okay, I mean, think of a place like, I think maybe like Fresno or a place like that. You have the city center with high-rise buildings and so forth, but then we have very large areas where you basically have, farmers doing their farming. And so, and then the political affiliations are very different between the inner city and suburbs and the rural areas. Okay, so suppose this county consisting of 6 areas shown below, and they're supposed to have 2 congressional districts. In other words, this entire place is going to have 2 House of Representative members representing them in Congress. The urban neighborhoods, 3 and 4, these are Democrats dominated, and the other areas are Republicans dominated. Not surprisingly, this is often the case. The numbers of registered voters in each area are shown right here. Okay, so this is the data that we are going to go by, and we are going to do just a lot of addition, just basically adding some of these numbers together to see what happens. All right, so now you can't decide to, for instance, just have one region 1 or area 1 as a legislative district, because that doesn't have enough population. Okay, and so we have some restrictions based on fairness and the law and so on. And so number 1, the first restriction is, in order to maintain equity and fairness, one district can't be much bigger than the other. Okay, so for this county, again, this is for this particular made up situation, each district must have at least 4,500 voters. Okay, now notice here we have a total of 1,000 voters, or 1,000 people voting. And so if you split this into 2 districts, most, on the average, you are supposed to have just about 5,000 in each district, right? But it is of course very difficult to break this up into exactly the 2 districts of 5,000 and 5,000. So let's say that it's okay to have a few, voters, a few more voters in one over the other. So in this particular problem, we assume that each district must have at least 4,500 voters. Okay, it can't be any smaller than 4,500 voters. In addition, each district must be connected together. Okay, so if you look at this here, areas 2 and 3 are separated by this 4, right? So 2 and 3 cannot, just the 2 of them cannot make up a legislative district, because that's not connected. All right, and then areas 1, 2, and 3, that's okay, because 1, 2, and 3 would be a connected chunk of land. Okay, so there are 2 requirements. 1, each district must have at least 4,500 voters, and number 2, each district must be connected geographically. All right, now here's the situation. Let's suppose that currently areas 1, 2, 5, and 6. So I should maybe circle these. Okay, 1, 2, 5, and 6. So that would be 1, 2, 5, and 6. Okay, so that's right now the district 1. Currently, areas 1, 2, 5, and 6, and they're all Republican dominated, by the way. Okay, so if you look at 1, 2, 5, and 6, okay, you notice here in each of these, there are more Republican voters than Democratic voters, right? So in each of these, the Republicans rule, and therefore, as a whole, this district will choose a Republican candidate. Okay. So that's District A. We're going to call this District A, right? Now, the other ones, I'm going to use the regular blue for Democrats and red for Republicans. That makes things a little easier for us to understand. Areas 3 and 4, that's the urban city centers, the central areas of the city. Areas 3 and 4, both democratically dominated. Notice here, there are more Democrats in each of these areas than the Republicans. They form District B. Okay, so now let's suppose that, let's verify first of all that the District A will elect a Republican and District B will elect a Democrat. That's pretty obvious. Okay, but also let's check for that the first requirement that each district has at least 4,500 people. Get that? All right. So look at these, and I am going to just here. Let me try to copy these numbers so you and follow along with me as you write these numbers. Okay. So how many Republicans are in District 1? Okay. So District A. Let's use red. District A has 1, 2, 5, and 6. So I went ahead and wrote the areas 1, 2, 5, and 6 here. And all you have to do is really copy these numbers, 550, and then Democrats. There are 500 Democrats in area 1. For area 2, you have 600 and 510. And then we skip to area 5 that has 460 and then 380 Democrats. And then area 6 has 990 Republicans and 710 Democrats. In District 2, I'm going to use blue for this. That consists of only areas 3 and 4. So these are the areas. In area 3, we have 1,300 Republicans, 1,600 Democrats, 1,080 Republicans, and 1,320 Democrats. Okay, so all you have to do really for these things, these numbers, is to add them. Okay, for each column. So go ahead and add 550, 600, 460, and 990, and you should get 2,600 Republicans in District A, where if you add all of these 4 numbers here, you only get 2,100. All right, clearly District A, well, I mean, the fact that, you know, in every small area, the Republicans dominate, each area tells you that District A will go for the Republican candidate, but it's again verified by this total number, right? And then let's add these together, because we need to find out how many people actually are, how many voters are in District A, and it turns out to be 4,700, right? Now, what was the requirement? At least 4,500 voters. So this is okay. District A is not quite 5,000, but it does satisfy that minimum requirement. For District B, remember the city center, if you add up these two numbers here, you get 2,380 Republicans, and then 2,920 Democrats. Okay. Let me box the dominating party in each district. What is the total of these two numbers? It turns out 5,300. Okay, not surprisingly, 5,300 plus 4,700 becomes 10,000, which is, of course, the total. Oops, the total number. Where am I? Total number of voters in this county. All right. So this is easy, right? I mean, all you have to do is to pick up the right numbers and add them up, and you can see that number one, each district satisfies the minimum 4,500 voter requirement, and number two, District A will go for the Republican candidate, and District B will choose the Democratic candidate. All right. Now let's go to number 2. Suppose then someone proposed that areas 1, 3, and 6 form a District A. So this is, you know, this is again, maybe after the census, they're about to redraw these congressional districts. And someone proposed, hey, I want, instead of having 1, 2, 5, 6 as the first district and 3 and 4 as the second district, how about 1, 3, and 6? Okay, so now let's take a look at 1, 3, 6, like that. Okay, how about 1, 3, 6 as the first district or District A, and 2, 4, and 5 as District B? Explain why this is not allowed. Okay, so that's the first district, and the second district will be something like this. Okay, now let's look at this district, and you can check on District A and District B. Well, let's do District A. If you look at how many people would be voting in District A, what you have to do is, let's see, District A is supposed to be 1, 2, no, so 1, 3, and 6, right? So let's add 1, 3, and 6. That's 1,500, and then 2,900 and 1,700, right? Okay, so if you go ahead and add these up, you will see that District A has enough people, in fact, 5,650. But that sounds a lot, right? Because you're supposed to have about 5,000. And so 10,000 minus this number, yeah, that's going to be too small. I think you can see that, right? If you add up the areas 2, 4, and 5, you don't actually have to do this. All you have to do is to subtract 10,000, this number from 10,000, and then you can get the same answer. But if you manually add up the populations or the numbers of voters of 2, 4, and 6, that's this, this, and this, right? So it's 1,110 plus 2,400 plus 840, and you see that this is going to add up to 4,350. Okay, so this is no good. All right, so this is less than 4,500 voters. Okay, now do you see why this is not allowed? Do you see the reasoning behind it? Yeah, because in Congress you want each district to be about the same population, so that each congressperson represents about the same number of people. This is just in the spirit of democracy or equity. So they have this rule that each district must have at least 4,500 voters. So this is too small of a district. So the District B is going to be too small, and that's why this idea is not allowed. It is in the violation of the law. You cannot do that. Okay, number 3. Someone else proposed that areas 1, 2, 4, and 5 form a District A, while areas 3 and 6 will form District B. Let's go ahead and try to do this. 1, 2, 4, and 5. I'm going to erase this. 1, 2, 4, and 5. Are they connected? Sure they are. Okay, so if this is District A, and then the District B will be 3 and 6, and so that seems to be okay geographically, at least. Okay, now we have to verify the population requirement. But suppose that someone else proposed this, District A shall be consisting of areas 1, 2, 4, and 5. It's different from the original, the current situation. Now you will see soon why somebody may want to do this. This is redrawing in order to take advantage. So that your political party will gain an advantage. And then District B will be the remaining 2 areas, 3 and 6, which is City West and Suburb South. Let's go ahead and add up these numbers. Okay, so again, from area 1, you can put 550. These are the same numbers as what you saw here. And then number 2, area 2 has 600. Republicans and 510 Democrats. 4 has, now you have to go here, right? It's 1080 and then 1320. And then finally, District 5 has 460 and 380. Okay, so if you add up these numbers, you will get the answers on the bottom. And so this will be 2690. And then the number of Democrats will be 2710. So just according to this, it's very close, but theoretically, District A will go for a Democratic candidate. Let's make sure that this is big enough, at least 4,500. If you add up these two numbers, you get 5,400. I guess you have to have at least 4,500. Now we have 5,400, so that's plenty. All right, and then we go to this other side. Let's go to areas 3 and 6. Area 3 has 1,300 Republicans and 1,600 Democrats. Area 6 has 990 Republicans and 710 Democrats. And so if you add up these numbers, District B will have 2,290 votes for the Republicans and 2,310 for the Democrats. I guess, again, this is very close, but the Democrats will be the winner. How about the total? The total number of voters in District 2 is going to be 4,600. Of course, this number can be obtained by subtracting 5,400 from the total population of 10,000. But you do, this is big enough. Remember, the minimum requirement is that 4,500 voters must be present. So this is enough. And so, and remember, we saw that both of these districts are geographically connected. And so that is fine. And guess what happened? Whoever this someone was, whoever proposed this redrawing of the districts must have been a Democrat, because currently, okay, District A is strongly Republican dominated and District B is strongly Democratic. But by redrawing the map, okay, redrawing the district boundary, you could, basically what happened is the sort of a political manipulation, right? Because if you redraw your districts in this way, District A will go for the Democrats, close, but the Democrats will win, and District B also will have a Democratic candidate. So that is an example of gerrymandering or Gerrymandering, depending on how you would want to pronounce it. Okay, so that's it for this section. And now I want you to use what we just learned. Okay, remember, the only operation involved here was addition. Okay, so try to do what we just did for this exercise. This is actually an exercise in the book in section 8.2, but this is also your quiz for section 8.2. The numbers are given and the requirements are given. You answer a few questions, basically 2 questions, and you should be set. This is not difficult, all right? But I do want you to have your first-hand practice on gerrymandering, not because I want you to do this in the future, okay, political manipulation, but I want you to be aware of what can be done by other people, people who want to gain advantage, maybe unfair advantage. And I want you to know what happens, okay, what really takes place in the world of politics involving mathematics. All right, so that's it. And make sure you do your homework as well, right? So this is section 8.2. Next time, we will cover the very last section in this course, which is section 8.3. So have a wonderful day, and I will see you later.